Hello, students. This is going to be a series of lectures which we are recording for the purpose of your home study. This basically is going to be a series of small video presentations so that you can simply be aware of the topics of chemistry. Uh, so basically, chemistry is a branch of science which deals with the study of composition, structure, and properties of matter and the changes which the matter undergoes under different conditions. There are going to be various topics I'm going to cover in this series. Today's topic I have taken scientific notations. As you have all studied scientific notation in your earlier classes, it's pretty much the same. So we can write a number as big or as small as we can imagine in the form of scientific notation. So for a big number like these, we can write it in the form of a scientific notation as, for example, 72 into 10 raised to 4. 4 is the number of zeros which follows 72. Similarly, for this number, if the number is a decimal number, I can write 0.0056 as 56 into 10 raised to the power of minus 4. Minus 4 because there are 4 digits after the decimal point. Okay, this basically scientific notation we use while multiplication, division, addition, or subtraction. So for doing these operations, we can use scientific notation for ease of calculation. For example, if I want to multiply two numbers which are present in scientific notation, I can simply follow a couple of rules where I can multiply the two numbers and I can add the power of 10, which will fetch me the answer. Similarly, for division, the rule follows is the two numbers are divided and their powers of 10 are simply subtracted to give the answer. Had we tried to divide the numbers in their real form, it would have been really difficult. Similarly, for addition or subtraction, the numbers are simply added or subtracted and their powers of 10 are taken common. If in case the powers are not same, then we can make some changes in the real number and then add it or subtract it and simply get the answer. These are pretty simple rules, and I'm sure you have studied it in your earlier classes. Basically, significant figures is the topic for today's lecture. Significant figures is important because if I'm measuring something, it is necessary to understand how accurately my quantity is being measured. For example, if suppose the mass of an object I'm trying to weigh is 12.3228 grams, I will be needing how accurate the balance I'm using is. That means I will be needing to know how accurately the mass of that object that I'm trying to weigh is. For example, what if it is 12.3228 and not 12.3229 or anything? What if there is a slight difference, or what we say the error is? We need to understand how accurate our balance is, how accurately we are trying to weigh our quantity, and what is the percentage error involved. The importance of these things you will slowly understand as we progress. So basically, significant figures is a collection of all the certain and uncertain digits in a number. Its definition is it is the total number of digits in a number including the last digit whose value is uncertain. Basically, you're going to understand it more when we start doing the examples. So let's proceed with them. There are certain rules to decide the number of significant figures in a number. For example, all the non-zero digits of any number are always considered significant. So basically, you can understand by meaning significant which figures we are going to consider as important in a number, which figures we can ignore, which figures we can round off, and so on. So you will be understanding. For example, in this number 569519, all the numbers are non-zero and it is a 6-digit number. So all the numbers are going to be significant, and this number will be said to be having 6 significant digits. I hope this is clear for now. So we proceed with the other rules. All the zeros between non-zero digits are significant. Again, for example, 34009. Here zeros are going to be are falling in between two non-zero numbers, so these zeros are going to be significant, and this number in nutshell will be having five significant digits. For example, if I have a decimal number, for example 56.0032 will be having say 1, 2, 3, 4, 5 and 6, so total 6 significant digits. Here I am not going to consider if these zeros are going to be in between or sorry, in before or after the decimal. Since these zeros are falling between two non-zero digits, they are all going to be considered as significant. Now, zeros on the left hand side of first non-zero digit are not significant. So basically any zero that is going to precede the first non-zero digit in any number are going to be non-significant. So for this number, since here there are a lot of zeros before the first non-zero digit, these zeros are going to be non-significant, and this a figure will be having only two significant digits. Had there been no decimal here, and had there been 0.00033, here also the number of significant digits will be 2. Next, zeros on the right hand side of the last non-zero digit are non-significant. So for example, 4 followed by 5 zeros will have only one significant digit. However big the number is, if there are many zeros following the last non-zero digit, those zeros are not going to be significant. So as big as a number is, we are only going to count the we are only going to count till the last non-zero digit. That's what is going to fetch us the number of significant digits in that number. So for example, 100 will be having only one significant digit, so will be for this number. So 4 followed by 5 zeros will also be having a one significant digit. Next rule is zeros on the right hand side of the last non-zero digit after the decimal are significant. If there is a decimal involved, all the zeros are going to be significant. So for example, 45.5000 will be considered. So in this number, we are going to consider all the digits, and this number will be having a total of 6 significant digits. There is a reason why we consider these zeros as significant, because we now surely know that after the 5, after the last non-zero digit, the next three digits are going to be 0. If we don't consider these digits, there might be some number that we might not be able to understand or comprehend, and that is the reason, since they are 0, we are going to consider them. That gives us the surety and the accuracy of this particular number. Okay, if you cannot understand this, just mark it away, and I'm going to make you understand later. Proceeding with the rules, the last rule is the power of 10 is always insignificant. So if I'm writing a number in the form of scientific notation, I am sure you remember we studied it just 2 3 slides back. If I'm writing a number in scientific notation, the number of digits of the power of 10 are always going to be non-significant or insignificant. So for example, 45 into 10 raised to 5 will only have two significant digits. This number is not going to follow. Anyway, if I write it in the long form, for example this, it is all again considered to be of the same type, and it will have only two significant digits, just like this number. This is a small exercise that you have to do. I would want you to write these numbers and find the number of significant digits, although I do have the answers ready which you can, and but of course I want you to try them, and we'll see if you have any doubts, we'll of course clear them. The number being greater than 5 and less than 5 is 5. So if the number is 5, okay, I want you to listen to this very carefully. If the number is 5, I will see if the number, if the last significant digit in that number is even or odd. If the number is odd, I am going to add 1, and I'm going to make this number 63400. Why? Because the first non-significant digit is 5 and the number preceding that is odd. So if it is odd, I will add 1. If it is even, the number will remain same. Now since these are 3 and 2, these are pretty small numbers. Even if it had been 9 and 8, it would have been the same. So if the number preceding 5 is odd, I'm going to add 1. If the number preceding 5 is even, the number will remain same, followed by zeros, of course, to the number of significant digits desired. Now, for example, this is a decimal number I am taking an example of. If I have 6.2351, again I am rounding off to three significant digits. Now, before 5, the number is odd, so it will become 6.24. If it is 6.2251, now again the number preceding 5 is even, so the number will remain unchanged. It will become 6.22. This is also a small exercise for you. I want you to round off these digits, these numbers to four significant digits. Of course, I have answers ready, but I want you to take up this exercise. And if you'll have any doubts, of course, we'll clear them when we meet. Or uh, maybe you can convey your doubts. I would try to clear them as soon as possible. You can simply write them up, but I would want you to try this up seriously. And if you have any doubts, you can get back to me and I'll be very pleased to clear them up. Thank you.